Hello, everyone. It's good to be with you, even if only remotely. What I wanted to share with you today is some research on the effect of early life, as early as before birth, exposure to stressful environments on outcomes over the life course. Specifically, what we're going to be discussing today is some of my research on prenatal exposure to environmental stressors on children's outcomes during the early years of life. So I'm a scholar of stratification mainly. So let me, in way of motivation, say why I'm interested in early life exposures. The reason is that there is growing evidence suggesting that early life experiences, starting, like I said, before birth, shape individual ability, health, and economic well-being over the entire life course, such that, as some scholars have put it, a child that falls behind may never catch up. What I wanted to do today is to examine the effect of one particular exposure, that is exposure to stress. Why stress? For two reasons. First, exposure to stress is highly prevalent in contemporary societies. And second, it's unequally distributed along axes of disadvantage, so socioeconomic advantage and ethno-racial lines, among other sources of disadvantage. As such, stress may play a relevant role in the intergenerational transmission of inequality. To date, the literature focuses on chronic stress, so the persistent, continuous, repeated exposure to stressors. And of course, that is extremely important. But I want to claim here that acute exposure to stress could only be toxic, especially if it happens early in life. The reason is that the prenatal period is full of sensitive and critical developmental stages. So those stages create windows of opportunity with long-term consequences. If stress exposure occurs during these windows of opportunity, then their effects may carry over the entire life course. This question, I claim, is very important for scholars interested in inequality and its transmission across generations, but it's challenging. And one important challenge is unobserved selectivity. That is, people, in this case pregnant women, exposed to stressors might be different from their peers who are not exposed, and different in ways that is hard to observe. One way to address this concern is to use natural experiments, right? These exogenous sources of stress in which stress is allocated as random. That's what I'm going to use here. I'm going to examine the effect of prenatal exposure to an acute environmental stressors on children's cognitive and educational outcomes, relying on a natural experiment. And in particular, I'm interested in whether this effect varies by family socioeconomic advantage. So the stressor here is the 2005 Tarapaca earthquake, a very strong earthquake that hit the northernmost region of Chile, and that provides the setting that I'm looking for. In order for an event to provide a natural experiment, at least two conditions need to be met. First, the allocation should be random. This is rather easy to ascertain in this case, because with the current technology, it's impossible to predict when and where an earthquake will strike in a context in which earthquakes are prevalent, of course. The second condition is the following. The effect of the event on the outcome of interest needs to go through entirely through the predictor that I'm interested in. Let me explain. If I'm interested in stress, the effect of the earthquake on any childhood outcome I'm interested in needs to go only and entirely through stress. So no alternative pathways of influence. This condition is called, this assumption is called the exclusion restriction. And it would be violated if, for instance, the earthquake caused death, disruption, a public health crisis, economic crisis, and so on. The reason why I use this particular natural disaster among the too many natural disasters that have affected populations over the last few years is precisely because, in spite of its strength, the earthquake had extremely limited consequences beyond the actual shock of experiencing the earthquake. So there wasn't economic decline, public health emergency, there wasn't much destruction. The reason for these very extraordinary circumstances is a combination of very high seismic preparedness in this country and low population density in the areas affected. So having set the stage, let me talk about the outcomes I'm going to be examining. I'm going to start with the first outcomes that can be observed after birth, that is birth weight. And other birth outcomes, right? Why to focus on these outcomes? Well, because they're the first outcomes that can be observed, and because these outcomes capture health, individual health, at the starting gate of life, so to speak. And now we know that birth weight predicts many outcomes throughout the life course: infant mortality and morbidity, but also physical and mental health, cognitive ability, schooling, and earnings, among other outcomes. So let me start with the first set of results. What we have here is the effect of prenatal exposure to the earthquake on birth weight. Birth weight I measure in grams, right? And the exposure, I'm going to distinguish 5 time points. So starting chronologically, these are kids born before the earthquake. And then those kids, so, you know, if you were born before the earthquake, of course, you couldn't be affected by the earthquake in utero. And then those exposed in the 3rd trimester of gestation, 2nd and 1st trimester of pregnancy. And then those kids that were conceived after the earthquake. I'm going to use a combination of this natural experiment with a difference in difference approach. So diff in diff means I combine 2 differences. I'm going to be combining over time differences, such as I outlined here, with a geographical difference. So I'm going to compare kids born in the affected area with kids born in similar areas of the country, but that were not affected by the earthquake or not directly exposed to the earthquake. So everything I'm going to do leverages this temporal difference, but it always is compared to with this control group, the kids that were not in the area affected by the earthquake. This is the first set of results. So solid dots are parameter estimates, horizontal lines are 95% confidence intervals, the 0 vertical line means no effect of earthquake exposure, right? And if, of course, if the confidence intervals cross the 0 line, it means no, an effect that is not significant at the 95% confidence level. So the results are easy to summarize. We observe that exposure, prenatal exposure to the earthquake is associated with a substantial and significant decline in birth weight only if it happened in the 1st trimester of gestation. This decline is about 50 grams, which is relevant at the population level, and if we use other exposures as benchmark, but we don't find any negative effect associated with exposure later in the pregnancy. No, I don't have a parameter estimate here because this category is used as baseline for comparison. this effect is significant, but of course the relevant question for those of us interested in population well-being would be, is it substantively relevant? I said, if we benchmark this based on compared to other studies, it is. But another way to look at this question is to look at a different dependent variable, or the reformulation of the dependent variable. So instead of using birth weight, I'm going to use the probability of being born low weight, that is being born with a birth weight less than 2,500 grams, that is less than a little over 5 pounds. Why this probability? Because low weight infants are at the highest risk of mortality, morbidity, and developmental issues. So if you're born low weight, is a good indication that you may be more vulnerable. When we do that, we find, we obtain similar findings. So exposure to prenatal exposure to the earthquake in the first trimester is associated with almost 2 percentage point increase in the probability, or the percentage in this case, of being born low weight. The average low weight birth proportion in this area, or percentage in this area, is 5%. So this increase of almost 2 percentage points means an increase from 5% to almost 7%. This is, depending on the size of the population, really substantial. And it basically means many more babies that were born low weight because they had the bad luck of being in utero during this earthquake. So, but this is only about birth outcomes, right? And a really critical question is what happens next with these kids. And there, in epidemiology, there are several theoretical approaches that suggest different pathways. So I'm going to very briefly go over them because they're going to be the basis of our hypothesis. First, there's this notion of chain of risk. Depending on your discipline, you call these many different ways, mediation and so on. So the idea here is that the prenatal exposure to stress affected birth outcomes, which in turn affected cognitive and educational outcomes among these kids, right? So it's a fully mediated effect. The second one is called, or we can call it, latency or alternative mechanisms. The idea here is that there is an effect on birth outcomes, but based on different mechanisms, there's also an effect on kids' cognitive and educational outcomes that remains latent until it's observed later on. The third hypothesis, of course, links the former two. The idea is that these two effects operate at the same time. You have a direct effect driven by some mechanisms, and an indirect effect mediated by birth outcomes. So the idea here is that at the same time, prenatal exposure to stress reduces birth weight, which in turn affects cognitive and educational outcomes, development, right? And then there are other, perhaps neurological or different mechanisms. Then there's the notion of fading out. Basically, the effect that we capture at birth disappears over time, that there's the ability to compensate, and that when you observe the affected kids later on, then we don't find any negative effect. And finally, we have the possibility that this is all driven by confounding, right? That there's unobserved factors, unobserved characteristics of the population affected, of the women who experience stress, that are also correlated with birth outcomes and with the kids' outcomes later on. Well, the use of a natural experiment and a difference in difference methodology attempts to address this question, right? However, the other four possibilities are certainly plausible. To address this question, what happens next? I'm going to combine this natural experiment with a panel survey. This is a survey based on a random sample of kids prenatally exposed to the earthquake and of observationally similar kids conceived at the same time but unexposed. So, who were born in a different region of the country. The total sample size is 1,200, and these kids were interviewed when they were 7 to 8 years of age. So we have here, what we effectively have is a panel of a longitudinal panel of the treated group and the control group. And in terms of the instruments, I'm going to use child assessments, the mother's questionnaire, and in-depth interviews with the mothers. In addition, the birth records for these kids were merged with the survey data, were merged with annual educational records. So effectively, I have an administrative panel, right, of these kids in addition to the survey. All right, so let's see what happens later on in this children's life when they're 7 to 8 years old. Their cognitive performance was measured using the Wechsler Intelligence Scale. This is a very well-established scale to measure cognitive ability or development that was adapted for the Chilean context, and to measure the effect of prenatal stress exposure on these children's outcomes. I distinguished overall cognitive ability, total ability, and then two of its components, verbal and performance ability. I'm going to capture here the effect of earthquake exposure in the first trimester of gestation using standardized scores of cognitive ability, right? So using the standard deviation metric. Again, I use the same methodology as before, so I'm comparing treated kids with control kids. These are the findings. Sorry, I switched the axis of the scale, so now the zero line is horizontal. And what we show here is for the entire population of kids exposed, there's a decline in cognitive ability of about 0.1 to 0.2 standard deviations, depending on the dimension of cognitive ability used. And this effect is not significantly different from zero. It's not altogether negligible in substantive terms, but it's certainly not statistically significant. This analysis is based on the perhaps naive assumption, however, that the effect of prenatal stress exposure would be homogeneous, would be similar, homogeneous across different groups in the population. But much empirical evidence and theoretical work suggests that that is not necessarily the case. And it suggests that the most vulnerable groups of society might be more strongly affected by this kind of exposures. So I'm going to relax this assumption of homogeneity, basically, and I'm going to allow for a socioeconomic heterogeneity. So this just repeats the analysis of effect on verbal ability, performance ability, and overall ability of exposure to this strong stressor in the first trimester of gestation. But I'm going to obtain these effects for three groups defined by mother's education: less than high school graduates, and moms with college education. So for each outcome, I'm going to divide the analysis. I'm going to stratify the sample by these groups. In the Chilean context, these groups are almost of equal size, so close to 3/3. And when we do that, we obtain a rather striking finding, which is the effect of prenatal exposure to stress is harmful and strong among the most disadvantaged families, those in which the mom has only less than high school diploma, but there is no effect whatsoever among more advantaged groups. In fact, the effect among the most disadvantaged groups is rather strong. It reaches between half and 2/3 of a standard deviation. For those of you who work in policy evaluation, an effect of about this magnitude is rather strong, and it means that it is the most disadvantaged kids that are affected by this further source of disadvantage emerging from an exposure that happened even before they were born. This raises, of course, the next kind of urgent question, which is what could account for this such pronounced heterogeneity in the effect that we observe? And I'm going to try, to the extent that is possible with empirical data, with observational data, to address this question. There are several hypotheses. Before we move to that, let me add this new part of the analysis, which is a subsequent outcome, kids' grades in 3rd grade. And we find exactly the same pattern. It's less pronounced, but we find also that the impact of prenatal exposure to stress on grades is more pronounced among the more disadvantaged kids. This is grades in 3rd grade, 4th grade, and 5th grade, and we see a pattern that continues over time. Let me move now to trying to understand why we observe this pattern of heterogeneity, in which the most disadvantaged kids are the most affected by this exposure. A very reasonable hypothesis that you may have been thinking about already is that what I'm calling stratification of the effect might be indeed an artifact of stratification of the exposure. In other words, the earthquake was caused different amounts of damage depending on socioeconomic disadvantage, right? This is very reasonable. Poor people have few resources to protect themselves, right? But in this particular case, because the earthquake had so limited spillover effects, this is less plausible than in other settings in which natural disasters have occurred. In order to measure this empirically, what I did was to use survey data to create an index of exposure. This index is based on 18 measures of how the extent to which families were exposed to the earthquake, and the items includes things such as whether the dwelling suffered any damage, whether electric power was lost, whether the respondent, a family member, or a neighbor were wounded or injured, whether the household suffered a drop in income, whether they had to temporarily relocate to a shelter, and so on. So I combine these indicators using a principal component analysis, and then I assess whether there is differential exposure across SES using the 3 categories I've mentioned. The answer is not very much. The disadvantaged families were somewhat more exposed, this is all standardized, right, than the more advantaged families, but all the difference failed to reach statistical significance, so it's unlikely that this stratification of the exposure was the factor accounting for the quite acute stratification of the effect. The second hypothesis is that even if exposure was relatively similar across the population, the reactivity or the sensitivity to this exposure may have varied, right? And there is several hypotheses suggesting that disadvantaged families may have been more reactive, more sensitive. For instance, among others, the allostatic load hypothesis would say that the chronic exposure to stress associated with poverty will damage the organism and will result in a novel exposure having stronger, more detrimental effects. So in order to assess this empirically, I created an index of reactivity using again survey questions. It's 11 indicators that I combine, including whether as a result of the earthquake, the people had much trouble sleeping, felt very scared, felt angry and irritable, had trouble concentrating, everything brought back memories of the earthquake, and so on. And when we see if there's differences across SES, again, there is some variation, right? There's more reactivity among the disadvantaged than among the advantaged populations, but the differences are very small in standardized terms, and certainly in every case insignificant. So the third possibility has to do with mediation. It's possible that prenatal exposure to the earthquake had stronger effects on birth outcomes among the more disadvantaged group, and that stronger effect on their birth outcomes carried over, right, over time, because we know that birth outcomes, particularly birth weight, predicts cognitive and educational attainment. So we can assess this, and this is the effect among all women, and this is the effect across SES. And you see that there is not much difference across SES at all in terms of birth outcomes. So that suggests that this is not the source of stratification of the effect. The fourth hypothesis has to do with parental responses, right? It's possible that parents with different levels of education and socioeconomic advantage, parents and families, I should say, and perhaps communities, engage in different responses based on different levels of ability to compensate for the effects of exposure. This hypothesis comes from much sociological and economic literature that suggests that indeed advantaged parents are much more able to compensate for any disadvantage or difficulty that they perceive their kids are experiencing. In order to assess this hypothesis, or better say, this is just a proof of concept, because it's hard to test this hypothesis using aggregate survey data, but what I did was to conduct in-depth interviews with moms with exposed children. And indeed, in these interviews strongly suggested that more advantaged parents both scrutinized their children's ability and development quite more deeply and consistently than disadvantaged parents, and B, were able to mobilize resources to address what they perceived as challenges and limitations faced by their kids. And these resources involved a wide range, including, for instance, the ability of moms to leave the labor force to stay at home and care for the child and pay more attention to the child's development, to drawing on recruiting medical experts, developmental psychologists, tutors, and so on to try to help their kids. So tentatively, I will suggest that these behavioral responses could compensate for the effect of prenatal stress exposure and would potentially explain why it is that we observe such a negative effect of prenatal stress exposure on disadvantaged families, but not among more advantaged families. So just to wrap up, early pregnancy exposure to an acute stressor, I found, has a detrimental effect on children's cognitive and educational outcomes, and this effect appears to persist over time from birth to childhood, even if it might be driven, the different effects might be driven by different mechanisms that involve many different systems, right? I found that it is not the case that a child who falls behind never catches up. However, it seems that the ability to catch up depends quite critically on economic advantage. This matters, in my opinion, in many ways to understand the persistence of disadvantage across generations, but in particular to the extent that prenatal exposures are unequally distributed, prenatal exposures to harmful contexts, right, are unequally distributed, and we know they are, they provide a potentially strong mechanism for the intergenerational transmission of inequality, and this mechanism can be easily mistaken for the transmission of genetic advantage or innate ability, because it emerges so early in the life course, right? Even before we're able to really measure. And this mechanism, very, very sadly, could be locked in early in the life course. With this, I'm gonna wrap up. Again, I'm glad to share this research with you. And if you have any questions, feel free to reach out to me.